Welcome to Module 6, Lesson 1, Algebraic Expressions. Today we're going to talk about how to apply properties of operations to add, subtract, factor, and expand linear expressions. So really what we're doing is we're focusing on how to write expressions, and we're focusing on how to factor expressions, and how to use the distributive property to expand expressions. All right, so we should be able to do each of these things pretty well by the end of this lesson. All right, so first and foremost, we have Jill and Kyle who get paid per project, and Jill is paid a project fee of $25 plus 10 per hour. Kyle is paid a project fee of $18 plus 14 per hour, and we're going to write an expression to represent how much a company will pay to hire both to work the same number of hours. So we're going to go ahead and we are going to highlight. So the question is saying write an expression to represent how much money the company will pay them both to work the same number of hours. Okay, so the important parts here is that one, we're writing an expression. So when you're writing an expression, we have to remember that there's no solution to an expression. Okay, there can be multiple solutions, so we're not putting it equal to something, because setting it equal to something means that there's only one solution. All right, and then another key part here is that they're working the same number of hours. Okay, so since they're working the same number of hours, that means that our variable can be the same. If they weren't working the same number of hours, our variable would have to be different, because we would have to be able to put in different numbers for Jill and Kyle. All right, so let's go through and find the rest of our important information. And get my tool ready here to box the important numbers and circle and such. So we have Jill and Kyle who get paid per project. So per project is going to be important. Okay, and Jill has a $25 fee, and I guess you can't see that if it's white, so let's try black. And actually for Jill, I'm going to do hers in purple so it's different. So we have Jill who has a $25 fee plus $10. Now that $10 is per hour. Okay, so that's important because that means that it's not just 10, it's $10 for every hour that she works. So if she works for 2 hours, that's $20. But then she also gets this fee of $25. All right, and then so next we have Kyle, and I'm going to do his in red. All right, so Kyle has a project fee of $18. And he also earns $14, but now that is also per hour. And now I guess I shouldn't have circled per hour, because per hour tells us that we're going to multiply. So per will be our to-do word for both of these. And then plus, so per, and then both of them have the word plus. So that's getting added to their fees. Now in this case, we can also say that hour is going to be an important number, because the number of hours that they work has to be included. But in this case, we don't know how many hours that they're going to work, so that's where our variable comes in. All right, so let's go ahead and start putting together our information. So we're going to write expressions for how much they will pay each person individually. So we'll put one together for Jill and we'll put one together for Kyle. Now for Jill, like we said, her and Kyle are both going to work the same number of hours, so H can represent the number of hours Jill or Kyle works. So we can say Jill and Kyle because of the fact that they are both working the same number of hours. Okay, so if Jill works 4 hours, then Kyle works 4 hours. Because of that, H can be the single variable. If Jill worked 4 and Kyle worked 5, we would have to use 2 different variables, so we could put in 2 different numbers. All right, So here we have Jill, and we know that Jill starts off with that $25 fee. All right, so she, no matter what, once she gets hired, she gets paid $25. All right, and then we know that that is plus, so we have the addition sign, plus, well, she's going to get $10, so it's not just adding the $10 though, it's $10 for every hour that she works. And the per told us that that was going to be multiplication. All right. So we knew that per told us that we were going to multiply. So we're taking that $25 and we're adding it to the $10 per hour. Okay, now when we have a number connected to a variable, remember that that means that we are multiplying. We can also add the multiplication sign in here just in case. All right, just as a reminder. So then Kyle will be much the same thing, except for Kyle only charges $18 for his project fee. So his project fee is less. However, when you add on his hourly rate is larger. So you add his $14 per hour. So $14 times H. Now again, since Jill and Kyle are working the same number of hours, H can be represented, or can represent both Jill and Kyle. If they were going to work different numbers of hours, Jill would have to have her own variable and Kyle would have to have his own variable, because in an expression, wherever you see a variable, let's say H is equal to 2, every H has to be replaced by a 2, or you have to substitute 2 for H. So if Jill worked 2 hours and Kyle worked 3, they couldn't both use H because they would both have to have different numbers put in for their hours. Okay, so that's really important to understand, is that when our number is going to be the same for both entities, in this case the entities are Jill and Kyle, then the variable can be the same. But when it's going to be different, the variable has to be separate. It has to represent the different numbers, the different pieces. So now what we're going to do is we're going to add the expressions together. So we're going to take Jill and we're going to add it to Kyle. So when we do that, we literally are just taking it and saying, okay, well, I am going to take Jill's 25 plus 10 times H, and I'm going to add that to Kyle's 18 plus 14 times H. But then now what I want to do, and we've talked about this before, is I want to combine like terms. So like terms are terms that have similar or the same features. So in this case, I have the numbers together. I have them color-coded for you. So both the reds are the project fees, and they don't have any variables because they are a flat fee. So these would be like terms. So again, the 25 and the 18 are like terms, so we could combine those. Then you have the 10H and the 14H. Now because they both have variables, we can look to see if they're like terms. Since they both have H as their variable, they are like terms. If one had an H and one had a J, they would not be like terms. They have to have the same variable. You can't combine two separate variables, but you can combine numbers that have the same variable. So in this case, it's as simple as you would think. You would add the 40 or the 25 and the 18 to get 43. You would add the 10 and the 14 to get 24. So that expression altogether would be $43 plus 24 times H. So what this means is the project manager, okay, so whoever hires, the company that hires them, is going to pay a flat fee total of $43. So they're going to pay $43 in total, not just to Kyle, not just to Jill, but in total. And they will also pay a total of $24 per hour. Okay, so now this company can look and see that even though they're paying two different people, they can have an idea, and this is actually our reflection question here. What can we read directly from 43 plus 24h that we can't get from these? Well, what we can find is how much we're going to pay in all for the project fee and per hour. So the company can determine right off the bat that they're going to pay a total of $43 no matter what, and they also know that every hour they're going to be paying out $24. All right, so if they're just looking for the total amount that they're going to pay, this single expression is helpful. If they're trying to split it up per person, then that's when we want the individual expressions. All right, but we can combine expressions, and that's what we're working with mostly today. All right, so then what I would like you to do is I would like you to try to simplify the expressions. So you want to find your like terms, and you want to combine them. Now you also have to remember that if it's a positive, so this would be a positive number, half is positive, and 4.5 would be negative because it's minus 4.5. So remember, this is like saying plus a negative. And then here, since this is minus, so this would be negative 25 hundredths minus 1 5/10. And this would be, so this is like plus a negative. This is negative 3 minus 1 4/10. All right. So go ahead and try it on your own, and when you come back, we'll check your answers. So 3 and 7 both are like terms because they both have x's, and you can add them. They're both positive, so you can just add them together and you get 10x. And a negative 4.5 plus a positive half will leave you with a negative 4. So you could have written this in two ways. You could have written this as 10x. I apologize that keeps disappearing. There we go. 10x minus 4, or 10x plus a negative 4. But I want you to get used to writing the plus a negative as subtraction. Okay? So then now here again, if you're struggling, practice and use that calculator. So I have negative 25 hundredths, so 25 hundredths, and it's negative, and I'm subtracting a positive 1.5. Oops. So 25 hundredths negative minus, and that's a positive 1/2, and I get negative 1 75 hundredths. I can combine them because they're both x's. Again, this is a negative 3 because it's plus a negative. So now I have negative 3, and I'm subtracting a positive 1 4/10, which will give me a negative 4 4/10. So again, I could have had negative 1 75 hundredths x plus a negative 4 4/10. Both of these would have been correct. However, you're more so going for the first ones. Again, we'll continue practicing with these. However, you got to get used to working with positives and negatives and fractions and decimals. All right, so example number 2. We are going to put together a problem, and then we're going to use the distributive property to simplify the expression to make it a little bit easier to work with. All right, so I'm going to jump straight to the question. I want to write an expression to represent how much the band gets to keep. Again, it's an expression, and now I'm going to look for my important information. So I know Mark is selling tickets for a high school band concert. The band gets to keep 25%, that would be an important number, of the money he collects from the ticket sales to put towards new uniforms. Well, ticket sales, so he gets 25% of the ticket sales. Well, remember, of, in this case, tells us to multiply. Okay, so they get 25% of the ticket sales. But now there's not that information about how much the tickets are inside of the problem. This is where I have to look at the other information and see that the tickets are written down here, and that adult tickets are $16.60 and youth tickets are $12.20. So even though this information isn't up in the problem, it's still within the problem. It's not up in the word problem. It's still part of the picture and it's still a part of the problem. All right, so you have to look at all the information and use everything that you can. So now in this case, the first thing that we are going to do is we are going to create variables, because in order to find the total sales, so in order to find out how much they make for all the tickets, we would have to know how many adult tickets they sold and how many youth tickets they sold, because they get $16.60 for each adult ticket and $12.20 for each youth ticket. So in this case, we can't just say T for ticket because the prices are different. Okay, so if I said T for ticket, I don't know if that ticket costs $16.60 or $12.20. So I don't know which number to put in for T. So that's why I'm going to use A to represent the adult tickets and Y to represent the youth tickets. So that way anytime I see Y, I know to put in $12.20, and anytime I see A, I put in $16.60. So then I also need to think about, what am I looking for? Well, I want 25% of the ticket sales. Okay, so if I want 25%, I know that 25% first has to get changed to a decimal. So I swing that decimal twice to the right and I get 25 hundredths. Okay. And I know of tells me to multiply, so I want 25 hundredths, so 25% of, so again, 25% of the ticket sales. Okay, so this is exactly what it says up here. Now I'm just changing it to an expression. All right. But now I have to put something in. I can't just put total ticket sales because there's two separate types of tickets. So how do I find the amount of ticket sales? Well, to find the amount of ticket sales, I would have to look at the amount that I made from the adult tickets, and I would have to add it to the amount that I made from the youth tickets. I know that the amount that I make from the adult tickets are going to be $16.60 per ticket. So it's going to be $16.60 times A, because A is how many adult tickets I sold, plus $12.20, because that's how much a youth ticket is, times Y, because that's how many youth tickets I sold. So if I do this, so if I add, or if I multiply these two, okay, it'll tell me the amount of money I made from the adult tickets. And then if I multiply these two, it'll tell me the amount that I made from the youth tickets. Now he gets the total, he gets all the ticket sales, so that's why we have to add those two things together. Okay, so in the expression, we are going to add those two things together. But once we add those two things together, what we have to remember is he only gets 25% of that. So we have to multiply all of that by 25 hundredths. However, we have to add that together first, so we have to figure this out first before we can find the 25%, which is why we would put it inside of parentheses. Okay, if we didn't, we would do 25 hundredths and we would only multiply it by the 1660, and then he would get all of the proceeds from the $12.20, and that's not how it works. He has to get 25% of this and 25% of this. So to make sure that that happens, we put this inside the parentheses to make sure that that happens first, because first we would have to find the total ticket sales. So now what we're going to do is we're actually going to use the distributive property to simplify the expression. The distributive property, look at the word distributive. It has the word distribute pretty much right inside of it. Distribute means that you're going to give something to everything on the inside. So we are going to distribute the 25 hundredths to everything inside of the parentheses. And we can only do this when we're multiplying, and we're multiplying by something that's inside of parentheses. All right, so I have 25 hundredths times 1660, and I have 25 hundredths times 1220. All right, so when I do that, okay, so I can distribute and get 25 hundredths times 1660a plus 25 hundredths times 1220y, and I can get one simple expression of 4 and 15 hundredths times a and 3 and 5 hundredths y. So then what this means is from every adult ticket, he'll get $4.15 of the $16.60, and from every youth ticket, he'll get $3.05. All right, I know this is confusing. Trust me, we are going to take some time on this, so take your time, practice it. We got to get really good with these word problems and setting them up, okay? So instead of using the distributive property to expand, could we have first found the sum of 1660a plus 1220y? So could we have first added these two pieces? If you said no, you would be correct. And we cannot do that because we can't find the sum of 1660a and 1220y because they are not like terms. Even though they each have a variable, one of the variables is an a and one of the variables is a y. Since one of the variables is an a and one of the variables is a y, we can't combine them. They would both have to have the same variable in order for us to combine them. All right, so what I want you to do is I want you to use the distributive property, and then I want you to come back and check your answer. All right, so here you should have distributed the 7 to both the 9 and the 6, and you should have gotten 63k plus 42m. Here you distribute the 2/10 times 3, and you got 6/10 b minus 3c. And again, you can use a calculator for this. That is perfectly fine. And then here, when you have 2/3, the way that I like to do this when I'm trying to do it in my head, make it easy on yourself. Okay, it would be 2, so it would be the numerator times the number. So in this case, 2 times 3, and then you would divide it by, 2 times 6, because you're doing 2 times the 6, and then you're going to divide it by the denominator, which was 3, which gave you 4. So then the next one would have been 2 times 9, and after you did the 2 times 9, you would divide it by 3. So 2 times 9 is 18, divided by 3, and that gave you 6. And then here you would have done 2 times 21, and then you would have divided that by 3. 2 times 21 is 42, divided by 3 would have given you 14. All right, then the next thing that we're going to look at is how to factor a problem. So we're going to use tiles. If the tiles confuse you, don't worry. We're also going to look at just doing it mathematically. So when you're looking at tiles, when we're factoring something, so think about if I were to talk about the factors of 6. So the factors of 6 are how I can break it apart into a multiplication problem. So the factors of 6 are 1, 2, 3, and 6. And that's because I can do 1 times 6, and I can do 2 times 3. Okay? So when we factor, typically we talk about numbers, but now we're going to factor an expression. So we're going to take this expression, and we're actually going to undo the distributive property. All right, so in this case, we have 4x plus 8. So to draw the model, we are going to use 4 x tiles, and we are going to use 8 1 tiles. So these are these 4 are x's, and then these 8 are 1s. So here's 4 x tiles and 8 1s tiles. Okay, so each of these are worth 1, each of these are worth x, and we don't know how much x is. Okay, and then what we're going to do is we're going to take our tiles and we're going to arrange them as a rectangle. Okay, so I have the 4 x's above the 8 1s. Okay, and the reason we arrange them as a rectangle is so we can look at them in terms of length times width. All right, because we know area equals length times width. All right, so to find this area, we're going to look at length times width, and in this case, so the width is going to be this one, and the length is going to be over here. Okay, so now when we look at this, the width, okay, the width is 1, 2, 3, 4 single units. So 4 single tiles, 4 1 tiles, okay, because each of these is worth 1. So the width is 4 plus 1 tiles. The length, so going down, because remember the width is just across, okay, and so here's the width right here. Okay, and no, the width isn't 4 x's because the x's, okay, the width, so from here to here is the same as from here to here. That's the width that we're looking at. Now we're looking at the length. The length is 1x plus 2 1s, okay, because we have 1 x tile and another 2 single tiles, so the length would be x plus 2. All right, so then now we would take our length and multiply it by our width, and our length in this case we said was x times 2, and then that would all have to be multiplied by 4. And I'm sorry, it's not x times 2, it's x plus 2. And that would have to happen first when we found our length, so that has to go in parentheses. Okay? But then now, to write it a little bit more neatly, we pull the 4 to the outside because we can rearrange it when it comes to multiplication, and we have 4 times x plus 2. So that's what's happening when you're factoring. Okay, you're pulling out a common factor of each of the numbers. You're pulling it out to the outside and keeping the rest inside the parentheses. Okay, and then this is again how it works. So you have your length times your width. Your width was 4. Your length was x plus 2. So you have 4 times x plus 2. Then to check, we can use the distributive property. We could distribute the 4. Okay, so again, we could distribute that 4 to the x and to the 2, and to make sure that we did it right, you would want to get your original answer. So your original expression. Our original expression in this case was 4x plus 8. So when I do that, 4 times x is 4x, so 4 times x is 4x, plus 4 times 2 is 8. So did I get my original expression? Okay, so this would so if I distribute it, this is what I would get, and it matches my original, so I know that I did it correctly. All right, so I want you to take a minute and I want you to try to factor each of these expressions. And actually what we're going to do is we're going to try the first one together, and then you guys are going to try the last few. So what you want to do is you want to look at the numbers. So we have 2 and 2. You want to find the largest common factor for both of them. Well, both of them have a common factor of 2. So 2 would go outside the parentheses, and then inside the parentheses, so 2x divided by 2 would be x, so all you had left is the x, plus 2 divided by 2 is 1. And now you have factored it. So again, find the GCF of the two numbers. Put the GCF of the parentheses. Divide and then divide. All right. And then just remember to keep the sign that's on the inside. So go ahead and try it on your own, and when you come back, we'll check your answers. All right, so again, we had 2 times x plus 1. Here, the common factor, the GCF was 3, so we pull out 3. 3 divided by 3 is 1, so we're left with x. 9 divided by 3 is 3, so we have 3 times the quantity x plus 3. The GCF here was 5. 5 divided by 5 is 1, so we're left with x. 15 divided by 5 is 3, so that's what stays on the inside. So we have 5 times the quantity x plus 3. And then here the GCF was 4, so we have 4 times the quantity x plus 4. All right, and I'm going to have you guys do your guided practice. This is a guided practice that is not actually going to go online because of the way that it is set up. And as always, if you have any questions, make sure to email me or write them down so that way we can go over them in class.